Hi, this is Bryan.D with Sprint 1 for networking games. So let's dive right in. So Sprint 1 was about making the game data-driven, which I did with the help of a couple of structs. One for the ship data and one for the state change data for when we have a centralized server. So yeah, I'm trying to show the state change as of right now is just a check to make sure that the states are actually in sync. So here we just saw we changed states and we added a point. So printed out game states were in sync. It also printed out when we first changed into the play mode. So now that we've seen that and we've seen the controls work, I'll show you exactly what I did. So let's start with the game manager. In the game manager, I added one struct state change. And this is the struct for changing the states. Each data structure has the process function that allows me to get rid of any if statements that would be put in the way. And so the other thing that I changed in Game Manager, I added a method for getting the player. That's for the ship data processing. And then the play screen update is completely torn up, basically. Right now it has code for both the local player and the client player. Obviously, the client player and code would be going on the client and not on the actual main one. But as it stands, this would just be taken out and put onto the client, and everything else would remain the same. Yeah, the way that I did the ship data being transported is I used a vec2, a float for the angle, an ID for which player the information's for, and then 3 bools for if they fired a missile, if they laid down a mine, or if they're respawning. In the process, I call get player to get the actual player, and then call update, a new update function on that player that is found right here. This sets the angle and the linear velocity, as well as calls the fire missile command in Game Manager, or the lay mine command in Game Manager, or the player killed command in Game Manager. Yeah. And then after all that's said and done, we run through the list and update all the game objects through their default update. I didn't want to do. I thought about putting that update function in here, but it wouldn't have been worth it because it's already in the game object list, and I would have to purposely not add it in there. It'd be better just to have all my game objects located in one spot. So the way that I did the queuing, I have 2 queues, an in queue and an out queue. An interface, they are queues of interfaces data that is inherited by the structs that are the data packets. They both have 2 methods, or add and then push out. Obviously, push out for out queue would be, networking out. Process for the in queue. Yeah, it basically just runs through all the structs and calls process on them. This is where I would get rid of this. This is where I got rid of the switch statement by using just a inherited member and then a process command. Yeah, I think that's it. So that's my data-driven network game.